So back to business. So we're done. We're modeling the situation as a strategic form game. Because agents make their bids sealed, they don't show it to anybody. It's a game in which as if they take an action simultaneously. So we can model it as a strategic form game. So we had two choices, modeled as a triple or modeled as a quadruple. At least one of your friends asked for the triple, so we will use the model in which preferences or numeric representations are over preference profiles, strategy profiles. So we specified who's involved. Now the strategy sets. So when you're writing the strategy sets, in this case, the strategy set of agent I, we're asking what actions can player I take? And be careful. I said, what actions can player I, bidder I, take? I'm not saying what actions will he take. The reason why we are modeling is in order to predict what he will, or in order to prescribe what he should do. But when you're modeling, you should ask, what actions can he take? Yes, ma'am? Real numbers? Real numbers?
Yeah, you can say any real number.
Any real number. Well, negative numbers?
Positive.
Positive or maybe non-negative. So, any number that they can write into the piece of paper is fine. Of course, they're bidding. So your friend says any non-negative real number. Again, as I said last lecture, this stands for the set of non-negative real numbers. Yes, sir? So another suggestion is, so that's one suggestion. Another one is, again, non-negative, but less than VI. Equal? Okay. That's another suggestion. Anybody else? Yes, sir? Bidding their own utility, which is what? Which is VI. So just VI. Anybody else? Yes, sir.
All in, everything he has.
Everything?
He has.
Okay, what does he have? So looking at the story, that story was available in the sheet that I distributed on Monday's lecture. So does it specify anything about how much money they have? There's no such thing. So if that's the case, I cannot model this situation. So maybe if you're modeling the situation, then you should ask the person who asked you to model this, how much money they have. Yes, sir?
Maybe 0 to maximum VI.
0 to? So another suggestion is 0 to maximum of over. So rather than, because I used I here, I will use Vj, where j is an element of n. Okay.
Do they know how much the other agents value?
Okay, so that's another thing that we have to be careful about. Well, for now, let's assume that they know. I don't know it as the auctioneer. I don't know how much you value it, but you guys know each other. So you might know how much you value, but we'll talk about that again later. But for now, to make life simple, let's assume that you do, but your friend has a point. If you don't know how much your friends value, how can you take an action in this set? That's why you asked, right? So your friend has an important point. So if you don't know how much the rest of the group values the object, this will not be meaningful. Okay? Any other suggestions? So let's take votes. How many vote for this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry? 9. There are uncountably many numbers, yes.
Take a minimum incrementation. For example, you cannot increment less than $1.
Okay, so, so you mean discretize this. Okay, so multiples of 1 lira or 1 kurush or whatever. But let's make it simple. Let's assume that you can even pay in arbitrarily small amounts. But yes, you can discretize it. But even with after discretization, if we follow your friend's recommendation, it will still be an infinite set. Okay? So we had 9 who voted for this. What about this? How many vote for this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14. So 14 here. How about this? 1, 2, only 2. This one? 1, 2, 3, 3. Okay. Now, let's start with this. If this was the case, would this be an interesting game? Right? So the player has only one strategy. There's nothing to predict. There's nothing to prescribe. There's only one thing they can do. And they will have to do that. Okay? So why VI? Why is the strategy set of player I just consisting of this? Why do you think that that is the case? Any idea? Yes, sir.
So he values the object as this, and in case he wins, he's not going to pay this. He's going to pay what is this.
So that's why you. Okay.
He can pay this.
Okay. Okay. But again, you see, this is why at the beginning I asked you, when you're talking about the strategy set, you should not think what they would do. You should think what they can do. You see, the whole reason of modeling is to predict, to guess, to prescribe what they would or should do. But if you say that this is, you're already making a prediction about what they would do without constructing the model. That's something which you should never do, okay? When you're constructing model, try to stay away from your intuition about what they would do. It's good to have some intuition, but use it at the end, okay? So that's not the case. Well, here, again, those who chose this set, why did they choose it? That was actually the largest group, 14. Why? Anybody? Yes, sir.
If we pay VI, for example, it shows the maximum amount, we will receive a utility of 0. And because we will pay. And the player prefers to winning the game, even though he gets a 0 utility, he prefers to winning the game rather than losing. So
Well, first of all, so your friend said if he pays VI, his total utility, whatever that means. Well, actually, let's talk about the preference there too. So the story tells, what does the story tell about the preferences? It says the players, the bidders, prefers winning the object if the amount that they have to pay is less than VI. He's indifferent between winning or not winning if he has to pay VI, okay? And he prefers paying less to paying more, okay? So if he wins the object and pays VI, and he doesn't win the object, so those two situations, one situation he wins the object, pays VI, another situation he doesn't win, he's indifferent between those two. He doesn't prefer one to the other. He's indifferent between them, okay? So why wouldn't he bid anything more than VI? Why can't he bid anything bigger than VI?
if he bids more than VI, he will pay more than the actual value of the object.
Okay, so if he bids more than VI, he will have to pay more than the actual object. So what?
But that's not worth it.
It's not worth it. So you're saying that he will never do something like that.
Probably he will. If he's the last player, for example.
If he's the, so, but again, you see what you're doing is, before finishing the modeling, you're making predictions, you're making guesses about what the players would do. Again, when you're modeling, that's something that you should not do. What can they do? If the value of the object, let's say, is 10 for player 1, on that piece of paper, can he write 20? Yes. He can. So that's an available strategy for him. Can he write 5? Yes, he can. So that's an available strategy. Can he write 4.9? Yes. Can he write 11.2? Yes. So again, when you're modeling, the question you should ask is, what can they do? Not what they would do. What they would do will come out at the end of the analysis, not at the beginning. Okay? Yes, sir.
But the agents are rational.
The agents are rational. That's so, and that's what your friend said. So, and that's what we're going to use when we're trying to predict what they would do. Okay? So if you, initially when you're constructing model, if you construct it by saying that this is what they would do, there's no point building the model. Okay? You already think that you know what it is. And sometimes our guesses, our intuitions can mislead us. Okay? So when you're modeling, that's a very frequently made mistake. When you're modeling, the question you should ask is, what can they do? Whether it's rational or irrational, what can they do? The agent values the object at 10 lira. Can he write 10,000? Yes, so that's an available strategy. Is it rational for him to do this? Well, we'll see at the end of the analysis. Our intuition says that he would never play something like that, okay? So at the end of the analysis, I hope we'll get a number which is not this big. If we get a number, if we say at the end of the analysis, we predict that the player will play this, then it means that either there's something wrong with our model, or something wrong with our analysis, or something wrong with our intuition. Okay? So, but again, this is an important point, and many people make that mistake. When you're writing the strategy set, you should ask, what can they do? Not what they would do. Okay? What can they do? Can they write any real number? Yes, they can. So that's R plus. Okay, so far so good? Any questions? So one more down, one to go. Again, now we have a choice to make. We're going to describe preferences of the agents over strategy profiles. We have two ways to do it. Write it as a binary relation, describe it as a binary relation, or give a numeric representation of the preference relation. You have to choose one. Which one? Well, we can do both, but let's start with one of them. Which one do you want? Numeric representation? Okay, so your choice was numeric representation. So what do we have to do? We have to find a function we want to find a function from the set of strategy profiles to the set of real numbers, which describes the preference of this agent. So what we have to do is we have to take any strategy profile, and the function should assign a number to the strategy profile in a way which represents the preference relation of the agent. So what would you write here? Yes, ma'am.
If the bidder is the highest bidder,
Second highest price. So if bidder I, so we're concentrating on a particular agent, okay? We're particular agent I, okay? So if agent, your friend's saying, if agent I is the highest bidder, then what was the rest?
then it will he will pay the amount that the rest of the highest of the rest of the
So if agent I is the highest bidder, then he will pay the highest bid made by the rest of the group.
Yeah.
So what?
And so our utility will be the value that we give.
The value, so the utility should be the value that the agent gets from getting this object
Yes,
minus
minus the amount that he will have to pay, so which is the second highest bid.
which is the second highest bid, which was, how do we describe it? The largest bid made by the other agents, that is, the maximum bid made by the other agents, which is, so this was in English, so let's write it in Matish. The maximum of S, so the maximum of the bids of the other agents. So in the strategy profile S, they bid, agent J bids Sj. So we're taking the maximum of Sj's where J is an element of n minus I. Okay? So far, so good? Yes?
But that's only if he is the highest.
Okay, so this is only if, yes, this is only if this is the highest bidder. So actually, maybe we should define it in pieces. So let's, by the way, don't write yet. We're in the process of discovering, and when we're discovering, we tend to make mistakes. Okay, so it's Vi minus maximum of Sj, where J is an agent other than agent I, if I is,
If BI, the bid that he gives, is the highest.
okay, well, we used symbol S, we could have used B, but if SI is the highest bid. So again, let's write that in. So you see, when you're doing these things, you speak in English or Turkish, and then you translate it to matters. So we go step by step. If,
If SI is greater than SJ for all J.
okay, SI is greater or equal to Sj
Not or equal to.
for all J, sorry?
I don't think it should be equal to or equal to. I think it should be strictly bigger.
Okay, let's go step by step. For every agent n, okay? Help me out.
For all J, an element of N minus I.
So for okay, SI, Sj, what is the relation between them?
Strictly bigger.
Strictly greater than.
Or maybe just the index of the SI.
Or the index of SI is?
Smaller
If they bid the, okay, so again, let's go back to the story. What did the story say? When there is more than one high bidder, which could be the case, you know, two of you might bid the same number, okay? What do we do? So when there is more than one high bidder, we could have equality. Okay.
But if that's the case, then we need to look at the index I.
Okay, so for agent I to be a winner, first of all, he or she has to be one of the high bidders. This says that he is one of the high bidders. But that's not enough. If there are other high bidders, his name should come before the other ones in the list. That is, his index number should be smaller than the others. So what does that mean? If there is some other agent J which bid the same number as agent I, then I must be smaller than J. For which J? For every J different than I. Okay. So this mathematical statement, let me write it nicer here. Let's use more space. Oh, yeah. If and this is the short mathematical symbol for and. Yes, sir.
Right at the very, where is the price of the gold?
Sorry? Oh, you can't see it from here? Oops.
I can see that, but
Yeah, okay. So is this part, okay? So for every J in N, Si is greater or equal to Sj. I did not remove I here because Si is equal to Si because I have equality here. I don't have to worry about that. And for any J, again, I don't have to worry about that. If Si is Sj is equal to Si, then I is less than or equal to J. That's the condition for agent I winning. Okay. This says that he has to be one of the high bidders. Okay. And this says that if there is another high bidder, his name should come after his in the list. Okay. He should be one of the high bidders, and he should come on the top of the list of high bidders. Okay. So far so good? Okay. Well, otherwise what? 0. Otherwise 0. That's it. We're done. This is a numeric representation of the preference relation of any player in this game. Okay? Any questions? Any questions? Yes, sir.
Why do we subtract maximum of SJs from VI?
Why did you do it?
Because the value of, so for example, if I value this copy for 5 euros, and then I bid, and then I have to pay 4, then my utility is going to be 5 minus 4.
Okay. But we usually don't like the word utilities. But that's close. But so again, first of all, there's 2 ways to think about net gain, which is what your friend said. Okay, if we think in monetary terms, when we say the value of the object, it's like when I get the object, it's like I earn this much money. Okay, so if I get that, this is the maximum amount that I'm willing to pay in a way. Okay. So if I have to pay this much, my net gain is the difference between those two, okay? Between what I was maximally willing to pay minus what I had to pay, okay? So why is that? Why does this represent the preference relation? By the way, this is not the only numeric representation possible. There are many other numerical representations. This is just one of them. But if we look at the story, so to check this, we have to check S, Ri, S prime, if and only if Ui S greater or equal to Ui S prime. Okay, so let's check. If under S and S prime, agent I is not the winner of the auction, then he would be indifferent between S and S prime, right? So these 2 numbers should be the same. Are they? Well, in both cases, he gets 0. Okay, so that passed the test. So let's assume that under this case, he wins the auction. Under this case, he does not win the auction. Okay, so the number assigned here would be Vi minus maximum of Sj, J in n minus I. And the number assigned here would be 0. So if this number is bigger than this, then it should be the case that winning is preferred to not winning. Well, what does this number being bigger than this mean? This being bigger than 0 means that the amount he has to pay is less than the value of the object for him. Okay? But what did the story say? It said he prefers winning the object to not winning it if the amount he has to pay is less than the value of the object for him. So that passes the test too. Okay? And I can go on, not winning the object, winning the object. If under S he doesn't win the object, the number assigned here is 0. If he wins the object, the number assigned is Vi minus maximum of Sj primes. Okay? So when is it the case that not winning preferred to winning? When that's the case. So when if this number is less than this number, if the amount he has to pay is more than VI. But again, what does the story say? It says, under this case, he prefers not winning to winning. So that's a numerical representation. But the main story is, how do we come up with this thing? Well, we look at the net gains of the agent. Valuing it means that it's like, if he gets the object, it's like he wins, he gets VI liras. And he has to pay this much, his net gain is this difference. Because the rule of the game says the amount he has to pay is the maximum bid made by the other agents. Okay? So that's what the rule was. The rule of the auction is, this is a different kind of auction. It's not the auction that we're used to. It's called second price. The second price comes, you don't pay the highest price, you pay the second highest price. Which what we mean by the second highest price is the highest price bid by the other agents. Yes, sir. Okay. Any other questions? Any other questions? So far, so good? Well, if you wanted to use the outcome function, again, we will not, again, unless you have to use it, you don't have to worry about outcome functions. But if you were to use outcome functions, what would be the set of outcomes? Sorry? Net gains. So what would be the outcomes? Winning, win, no win. Anybody else? Yes, ma'am?
Winning and have to pay higher than what your value is, and winning and paying what your value is.
So winning and paying what? Can you repeat again?
Winning and paying higher than what your value is.
Winning and paying what the value, higher than the value is. So that's in English. Let's write it in Mattish.
SI is greater than VI. Or it could be SI is equal to VI.
So are you talking about another outcome? So pick a single outcome and tell me, represent that in Mattish.
That's one outcome.
SI bigger than VI. That's one outcome. Another one? SI equal to VI. Okay. Anybody else? Sorry? And SI smaller than VI. Anybody else? Yes, sir.
I think we should just combine so winning. For each outcome, we should have winning, comma.
Okay, so let's write that too. So winning, comma, SI greater than VI. Is that finished? Another outcome?
Winning, comma, SI smaller than VI. And therefore not.
Okay, so far so good?
But it's not about SI being greater or smaller than VI, it's about the second highest bid.
It's about the second highest bid. Okay, so you see, first of all, don't be afraid of making mistakes. You see, we learn a lot from mistakes. And actually, my experience is that, both from myself and from the students that I have taught, those who are not afraid to make comments, those who are not afraid to make mistakes are the ones that learn the most, okay? So if I look at something like this, okay? So if I want to decide on this outcome, okay? What does that say? Is there anything about winning here? Okay. It's very, so actually, I'm going to map this. So if I read this outcome, I cannot interpret this outcome without knowing what SI is. I know what VI is because it's given in the story. It's a parameter of the problem. But I do not know what SI is. SI is something which agent I chose. It could be 1, it could be 3.2, okay? So a statement like this, saying that this is an outcome is not meaningful because I cannot tell you what this outcome is without knowing what SI is. And SI is not something which is fixed. So this statement that this is an outcome, the game resulted with this outcome, is not meaningful. For the same reason, this is not meaningful. Okay? So write these things down, but after you write it, scratch your head gently and ask yourself, does the answer make sense? Sometimes you will immediately see that it will not. Okay? So it can't be this, it can't be this, because irrespective of what these stand for, okay, I cannot interpret this outcome without knowing SI is. I know what VI is, it's given in the story, but I don't know what SI is. I don't even know what I is. Looking at this alone, I don't even know what I is. I can't interpret this outcome. Okay? Okay? So, when you're looking at the outcomes, when you're thinking about an outcome, you should think, well, we've done this auction. I'm auctioning this very valuable marker. You all bid. Actually, we're going to play this game. We bid. I took the bids, determined who the highest bidder is, and said, you get the object and you have to pay this much. And just at that moment, Emre Bey comes in. What does he see? He sees the outcome of the result of the game. What does he see? Well, what does he see? I say, you win the game. I give you the marker, shake your hand, and ask for your money. That's what he sees. What is that? Index of the winner and the money that you're giving me. He sees two pieces of information. Who got the object? How much does he have to pay? Okay, so just give me a minute. Let me write this and then I'll come back. So, who gets the object? So it's the name of the agent who got the object, I, and it's the amount that he has to pay. So let's denote it with P. So what is I and P? I have to specify it, otherwise I'll have the same problem I did before. What is I? I is an agent. What is P? P is a non-negative real number. So when I look at an outcome like this, what does that say? It says agent 2 win the object, win the auction, won the auction, and he has to pay 4 liras. If I see an outcome like this, agent 5 won the object, the auction, and he has to pay 2.6 liras. Okay? Okay? So far, so good? You had a question? Okay, good. Thinking is always good. Okay? Don't be afraid of making mistakes. Okay? But once you make, once you write something down, once you get to a conclusion, put the pen, pencil, marker, whatever down, scratch your head, ask yourself, does it make sense? Many mistakes you can catch it like that. And once you find it, you notice where the mistakes is, and then you fix it, and you come up with an answer. Of course, this is not the only way to model the outcome. There are many, many ways, but this is the simplest, most natural. Okay? So when you're looking at the outcome of a game, just ask yourself, well, there's two ways. Ask yourself, somebody who enters the room just when the game ended, what does he see? Okay? If it was chess, he could see white winning, black winning, or a draw. So there are 3 outcomes in chess. White wins, black wins, draw. Here, what do they see? Agent 3 getting the object and paying 5 liras. Agent 5 getting the object, paying 2.6 liras, whatever. Okay? That's one way. The other thing is, actually, when you read the story tells you what the outcome is. Remember, what did we say? We usually, in the descriptions of the games, preferences are given over outcomes. So when you read the story, what does it say about preferences? It says he prefers winning when the amount he has to pay is less than the value of the object. So what is he comparing? He's comparing whether he wins or not, but that's true for every agent. So he's comparing who wins and how much is paid. So the story also gives you a clue about, read the part about the preferences. The part about the preferences will give you a clue what the outcome is, what the set of outcomes is. Okay? So far, so good? Any questions? Okay? So I'll leave it to you to write the outcome function and write the preferences or numeric representations of the preferences over outcomes. So if you were to model this not as a triple but as a quadruple, how would you model it? I'll leave that as an exercise to you. Okay? Any questions? Any questions? Okay? Okay? Okay. Let's do, shall we do one more or play a game? Start analyzing it. Well, let's do a fast one, easy one. Econ students are already familiar with this. The Cournot duopoly, okay? Not duopoly, the Cournot Oligopoly, okay? So what do we have? Again, it was in the sheet, so please read it. I'm not going to write it here. Actually, I can put it on the screen. But while I'm putting it on the screen, I'll tell you the story. We have n firms that produce identical goods, okay? We have n firms that produce identical goods. Where is it? Well, that will come up. As I tell the story, we'll start modeling, so I'll do the easy part. Because there are n firms, the set of players is integers from 1 to n, firm 1, firm 2, and so on. Each firm decides on how much to produce. So that should also tell you something about the strategy set of the firms. What is it? They decide on how much to produce. So that's in English. In Mattish, it's a, come on, don't be shy. You just a quantity. It's a, well, non-negative. So you might say, I'm not going to produce anything. Okay. So the strategy set of firm I is R plus, non-negative numbers. Again, in the previous case, I forgot to mention. But every time you write this, you should tell what an element here represents. So where Qi in Si represents the action of producing Qi units of the good. Okay. It can't, well, you could produce 2.5 kilograms of rice or sugar or whatever. Yes, sir. Well, so the notation that I use in this class, that I will use in this class is R plus is the set of non-negative numbers. R plus plus is the set of positive numbers, okay? So the firm might say, today I'm not going to produce anything. We're closing the store, okay? But that's the notation that we will be using, okay? Again, whenever you write this, you should tell us what this is a mathematical object. You have to tell what that corresponds to in the world, okay? So a number here, 5, player I choosing 5 here means that player I decided to produce 5 units. The 5 could also mean player I decided to sell at 5 liras per unit, okay? So you have to tell what that number stands for. So in the previous case, I should have also done it. I forgot it. So in the sale bid auction case, SI denotes the situation where bidder I bids SI liras. Okay? You should always do that. Always make habit. Just because you know what it stands for doesn't mean that your reader will know what it stands for. So, one more down. Now about preferences. Well, for preferences, when we read the story, it didn't come up. wait a minute, what happened? Ah. Ha. Well, let's wait. Yeah, sorry about that. Okay, so what happens is, so firm 1 decides to produce Q1 units, firm 2 decides to produce Q2 units, firm N decides to produce Qn units. We add them up. We find the total quantity in the market. So let me denote that. Did I use a special symbol there? Unfortunately, I did not. So let me call this QT, Q total. Okay. So that's the total quantity in the market. Well, there is the market demand for the good. Okay, so we have the market demand for the good. So in order to sell QT units, the the price of the goods should be P of QT. Okay, that's the market clearing price for QT. That's given by the demand. So here, the consumers, the demanders, are not players. Their decisions is already summarized by the demand function. Okay, that's why they're not in the set. So given the quantities that each firm will produce, that determines the total quantity in the market. Okay, and in the Cournot's model, that's how Cournot set up this model. They sell at a price at which every unit that is produced is sold. That is, they sell at the market clearing price. Okay, okay, and hence what happens? This is the market clearing price. Firm I produces QI units. So this is the revenue of the firm. And this is the cost to firm I of producing QI units. So that's the profit of firm. And what does the story say? Well, a higher profit is preferred to a lower profit. Okay? So how would you write the preferences? What would you use as a numeric representation for the preferences? Again, what did the story say? A higher profit is preferred to a lower. So, sorry? So I want to just set it equal to the profit, right? So actually, the profit function pi I will be a numeric representation of the preferences, as your friend suggested. Again, what did the story say? A situation where the profit is high is preferred to a situation which the profit is low. So just use the representation. So this is a numeric representation of the preference of firm I, where I is any firm. Okay? Any questions? Any questions? Okay? That's it. So this was a simple model. Yes, sir?
This is total profit.
No, this is the profit of firm I, pi I. Okay? Yes, sir?
What does Q1, Q2 mean next to the PR?
This one?
So,
This one? So, you see, we took SI. Usually we take small SI to be an element of SI. But this is just a symbol. It's a dummy symbol. So sometimes we can use SI, sometimes BI. For example, in the previous example, I said SI, but I could have as well used BI. Why? Because what is the actions that the players take? They bid. B stands for bid. What do the players do here? They choose a quantity. So I have two options. I can use SI, so I could say okay.
no, I mean, it can be Q or S. I don't mean that. So we say pi I is the profit of that term. So what does Q1, Q2 up to Qm means?
Okay. So again, what was the strategy set of each agent? It was a non-negative real number. So QI in here, the story, I just raised it, but it says the action of producing QI units. So when I look at this, your strategy, your firm 1, you have to choose on how much to produce. Your friend is firm 2, he has to decide on how much to produce. Your friend is Q3, she has to decide on how much to produce. So we take the amounts that firm 1, your firm 1, you decided to produce 2 units, your friend decided to 3 units, your other friend decided to produce 1 unit. So what happened? The total quantity in the market is 2 plus 3 plus 1. That makes 6. You're producing 2 units, so your revenue is 2 times P of 6. Are you talking about this P? No, okay. Minus the cost of producing 2 units. So your decision is how much to produce. So you say, I'm going to produce 2 units. She's producing 3 units. She's producing 1 unit. The total amount in the market is 6. So you don't set a price. You sell at the price in which 6 units is cleared from the market. That is, every bit of what is produced is sold. Okay? So in order for every bit that is produced to be sold, you have to sell it at the market clearing price. Okay? The price which is determined by the market demand. Okay? I'm not sure whether I understood the question and answered it correctly, but okay? Any other questions? So I'll send you on homework probably tomorrow via email. Next week, again, we'll use the spare hour. We'll use the spare hour for the upcoming few weeks. I want to pick up pace. These are very basic stuff. We have to get into serious stuff as soon as possible. Okay? That's it. Have fun.